So today we're going to talk about section 8.4, confidence intervals with proportions. We already talked about how to do confidence intervals for the mean, okay? And that depended on whether you knew the population standard deviation or if you did not know the population standard deviation. Okay, if you did know the population standard deviation, you would use the z distribution. To find our critical values, you would use inverse norm. If you did not know the population standard deviation, you would use the t distribution. And if you had it on your calculator, you would use inverse t to find the critical values, or you have to use the table. Now, for confidence intervals with proportions, do we have to use another distribution? We have the z, the t. Is there a different distribution for proportions? No, we're actually going to use the z distribution. Okay? Now, let's go ahead and talk about how do you know when you're dealing with a proportion. Alright, so if you look at my notes, you could read along with me. How do you know you are dealing with a proportion problem? First, it will be a binomial distribution, okay? Now, since it's a binomial distribution, when you take large enough trials, the distribution becomes approximately normal. We looked at a binomial distribution graph back in chapter 4 it was. In a binomial distribution graph, the histograms that we made had a shape that always looks something like that. But the more trials you have, it starts to look more and more normal, okay? Since it looks more and more normal, the more trials you have, this leads us to use the z distribution, okay? That's why we are using the z distribution here, okay? Now, what it means is that how you know you're dealing with a proportion problem, it'll be a binomial distribution. You only have two options, okay? For example, you are either a full-time student, 12 credit hours or more, or you are a part-time student, under 12 credit hours. You cannot be both. So you could call being a full-time student a success, and then the failure would be being a part-time student, okay? Nothing to say about students who are full-time and part-time students. All the students, hopefully they're all successful. Now, so what we can do for these problems is a lot of the time we have to find our proportion, okay? Our proportion here, and it's going to be a sample proportion p hat, okay? Remember this is the sample proportion, and then just plain old p is the population proportion. Alright, so when we make a confidence interval, we are making a confidence interval for the population proportion. We don't know what this is, but we want to find an interval that we can say we are however many percent sure that it's between these numbers. This sample proportion, as you recall back when we talked about confidence intervals for the mean, the sample mean was used as a point estimate. This p hat, our sample proportion, is going to be used as a point estimate, okay? Now, p hat is equal to x divided by n, where x is the number of successes and n is the number of trials, okay? So in some problems, they will just tell you p hat is equal to 68%, okay? Or they may tell you how, like if you're doing a survey, say it's just a very simple example, yes or no survey. X would be the number of yeses, so the proportion of people who said yes would be the number of people who said yes divided by the total number of people you asked. Okay, whatever the question was. Okay, now if we want to make a confidence interval, it's very much like what we did in the last two sections. We find our point estimate. We must find our error, which, if you recall, in the previous two sections, this is the only thing that was different, okay? The error formula. Otherwise, the process is very, very similar. It doesn't matter what section you're in. The error formula here is our critical number, z alpha divided by 2. We went over in section 8.2 how to calculate this. I'll still put it up on the board. And then times by the square root of p hat q hat divided by n. Okay? And if you recall, q hat is just going to be 1 minus p hat. Okay? Now, how to find z alpha over 2? Z alpha divided by 2 is equal to inverse norm of alpha divided by 2, comma 0, comma 1. And if you remember, we're going to get a negative value for this, for our alpha over 2. And if we're using the z distribution, I'll just draw a small one right up here. It's symmetrical, so this negative z value, all we have to do is find the positive z value over there. Just knock off the negative. Okay, and that's what's going to go over into here. Now, once we have our point estimate, once we have our error, our confidence interval is going to be p hat minus our error, comma, p hat plus the error. Just like when we did it for the mean, okay? It was x bar minus the error, x bar plus the error. So same exact procedure, okay? Now, let's go ahead. Oh, in my notes, there's a note that says only use the normal distribution, or the confidence interval can only be used if the number of successes n times p hat and the number of failures is n times q hat are both greater than 10. That'd be very similar to our central limit theorem here. We want them to be greater than 30, our sample size greater than 30. Like I said, very analogous to it for proportions. Let's go ahead and look at this first example. It says, suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. Okay, so what they're doing is going around and asking everybody if they have a cell phone or not. If you do, you're going to respond yes. If you don't, you say no. 500 randomly selected adult residents in this city, so they told us our sample size or number of trials is 500. Where are we? Selected to be surveyed, determine whether they have a cell phone. Of these 500 people surveyed, 421 responded they own cell phones. So responded yes. Do you own a cell phone? Yes, you do own a cell phone. This is going to be our X right here. Now, using a 95% confidence level, so our confidence level here is 95%. Compute a confidence interval estimate for the true population proportion of adult residents of the city who have a cell phone. Okay, the procedure on how to do this is exactly the same as we did last time in the last two sections, okay? We need to find our point estimate. P hat here is x divided by n, which is 421 divided by 500, which is equal to, let's see, 421 divided by 500, 0.842, okay? About 84% of people responded yes. Let's put that information up here. P hat is equal to 0.842. We could go ahead and find Q hat right now if you want. We are going to need it for the error formula. So if you remember, Q hat is equal to 1 minus P hat. You can just punch this into the calculator, 1 minus this answer, and you get 0.158. So like I said, we're going to need that. Let's see. We still need N. N is equal to 500. We don't need this anymore. We'll need our confidence level. So confidence level is equal to 95%. So that's all the relevant information we need right now. So we need to compute the error, which is Z alpha divided by 2 square root of P hat Q hat divided by N. Well, we have P hat. We have Q hat, we have N. So this part of the formula for the error is figured out. We need our critical number, Z alpha divided by 2. So we need to find what alpha divided by 2 is. If you remember, alpha is always 1 minus the confidence level, so it's 1 minus 0.95. You have to turn the percentage into a decimal, and you get 0.05. But that's alpha. We need alpha divided by 2, which is 0.05 divided by 2, 0.025, okay? So here's our alpha divided by 2. So Z of 0.025 is equal to inverse norm. It's my alpha over 2 value, 0.025, comma 0, comma 1. I think this is negative 1.96. Oops. Yeah. Negative 1.959 or negative 1.96. Now, we're going to just make it positive. Because we don't need the negative or positive value here. We just need the positive value, okay? Or I said we don't need the negative positive value. We don't need the negative value. We need the positive value. So now that we got this value right here, let me write it up here so I can erase stuff. Z of 0.025 is equal to 1.959. So we have all of the information we need to compute the error. The error is equal to our Z of alpha over 2, which is 1.959, times the square root of P hat, 0.842, times Q hat, 0.158, all divided by N, which is 500. So you could just input this straight onto the calculator, 1.959 times the square root of 0.842 times 0.158 divided by 500. And this gives us a value of 0.0319. Okay? So now, to find our confidence interval, P hat minus the error, comma, P hat plus the error. So all I'm going to do is take my P hat, I'm going to subtract this number, okay? If I do that real quick, 0.842 minus the number, minus our error, we get a lower bound of 0.8100. And then if we do P hat plus the error, I get 0.8739. So let's go ahead and talk about what this confidence interval means. We want to know the true population proportion of how many people own cell phones in this city. okay? We take a sample of 500 people. Now, if we were to keep on taking samples of 500 people, and we were to keep calculating confidence intervals in the same process, using the same confidence level every time, the point estimate's going to change, but that's okay. So then the error will change, so our confidence intervals are going to change. But if we keep doing this over and over and over and over, we're going to get a long list of confidence intervals. We should expect 95% of those confidence intervals to contain the true population proportion. Okay? Or another way of saying this is that we are 95% sure that our confidence interval contains the true population proportion of people who own a cell phone in this city. Okay? Now, on the test, when you have a test over this material, you will be asked to interpret the confidence intervals. You got to say something like what I'm mentioning to you now. Okay, now let's go ahead and learn how to do it on the calculator. You can get the same interval on the calculator. If you recall where the other intervals are, you had z interval and we also had t interval. Well, if you hit stat and go over to tests, and you gotta scroll down, it's option number 5. Okay, 1 proportion z. Oh, sorry, that's 1 proportion z test. Scroll down even further. My fault. It's letter A. 1 proportion z int. It stands for 1 proportion z interval. Okay? If we go ahead and hit enter, it asks us for the x value. It asks us for the number of successes, the n value, the sample size, and our confidence level. So it already has 241 plugged into there from probably a previous problem. I'm going to change it to 500, and I'm going to change our confidence level to 95. Notice when I enter in the confidence level, I entered it in as a decimal. Okay, make sure you put it as a decimal. If you put it just 95, it's going to spit out an error at you. Okay, you go to calculate. And it gave me the wrong answer. Give me one moment. Oh, 241, 421. That's what was wrong with my initial answer. Sorry about that mistake. So we had 420 respondents say yes. I put in 241 into there. So now if we go ahead and calculate, there we go. We get a much better answer. 0.8100 and 0.8739. Yes. So as you can see, it matches our answer that we got by hand. All right. So now I want to warn you about something when doing these problems. What they could have done instead on this problem, they could have said in a survey of 500 people, the proportion of people who own a cell phone in this city, say it's equal to, now we had 0.842, and if we multiply that by 500, so 0.842, when we're doing it on the calculator, you have to find the x value. If you remember the inputs on it, it asks for an x value and an n value. If you look at the formula, p hat is equal to x over n. If I multiply both sides by n, you get x is equal to n times p hat. Okay? So I could take 500 times this by 0.842, and that's going to equal 421. So the problem could have been worded where they gave you p hat and say you wanted to use the calculator, you have to find your x value, okay? Now, there's also another warning that comes with this. Let's say our p hat was 0.371. Let's go ahead and say we want to use the calculator. So to find x, I take n times p hat. 500 times 0.371 is equal to 185.5. Now, here's where you could think to yourself and think about what x is. X is a number of successes. Can you have half of a success when there's only two options, a success and a failure? No, you cannot. So if you're doing this on the calculator, let's go ahead and try this on a calculator. If I go to stat and go over to tests, and I go back down to, scroll down to A, 1 proportion Z interval, hit enter, it asks me for an x value, okay? Now, let's put in 185.5. Just keep the confidence confidence level the same. And now if I go to hit calculate, it says error, domain. What that is meaning is that this x value could only take on whole numbers. That's what I was pointing out. Can you have half of a success? No, you cannot have half of a success. So what you have to do, you got to either round up or round down. I'm not sure if the book gives you a convention, either rounding up or rounding down all the time. I'll check on that for you. But either way, you got to round up or down to the next integer, and you could plug in 186 or 185 into the calculator, and then the calculator will proceed to do the work for you. Now, if you do use the calculator with one of these rounded values, if you were to do it by hand, the answers are going to come out slightly different, okay? Because the point estimate for the calculator, when you pick one of these numbers, will be p hat is equal to 186 divided by 500, which 186 divided by 500 is 0.372. If I had to guess what 185 divided by 500 is, it's going to be 0.370. So if you could do this by hand using this number, but in the calculator you got to pick one of them. So then your point estimate on the calculator is going to be slightly different than your point estimate if you did it by hand, meaning your confidence intervals will be very, very slightly different. Probably see how the third digits are different, where the first two digits are the same. The confidence intervals are probably different in the last digits over there, which is very small, so it's pretty insignificant difference between the calculator answer and if you were to do it by hand. Okay? Now let's go ahead and talk about how to find sample size. Okay? What we can do is very much what we did in 8.2 when we found sample size, is just take the error formula and work backwards for n. So error is equal to z alpha divided by 2 times the square root of p hat q hat divided by n. So I'm going to have to z alpha divided by 2 divide both sides by this value. E divided by z of alpha divided by 2 is equal to square root p hat q hat divided by n. Now I'm going to square both sides, because then the square root and the square will cancel. I get e divided by z of alpha over 2 is equal to p hat q hat divided by n. let's see, we can cross multiply. We get n times z is equal, oh, that's all being squared. We still can cross multiply. Multiply this side by n, multiply this side by n. N times e over z alpha divided by 2 squared is equal to p hat q hat. And then we're going to divide both sides by this. And then we get a final formula for n. N is equal to, well, we got p hat, q hat. Now this is on the denominator. To put it on the numerator, I'm going to have to multiply the numerator by the reciprocal of the denominator. So flip the denominator and multiply it on top. So times by z of alpha divided by 2 divided by the error, all of it squared. Which you have the formula in my notes, but that's how you get to it. You just work backwards from the error formula. Now to do a problem like this, you have to have p hat, you have to know alpha, or your confidence level, and you have to know your error in order to do one of these problems. And normally they tell you all that to get n. So let's go ahead and look at that next example on the page. It's suppose a mobile phone company wants to determine the current percentage of customers age 50 and older who use texting on their cell phones. How many customers? So they're asking you how many. That means find the sample size. How many customers age 50 plus should the company survey in order to be 90% confident? So that's our confidence level is 90%. I'm just going to put it as 0.9. That the estimated sample proportion is within 3 percentage points. So they're telling us our error has to be within 3 percentage points. If it's 3 percentage points, we need to be within 0.03. Of the true population proportion of customers age 50 plus who use their text message on their cell phones. Okay, so let's see. Oh, they don't give us a p hat, do they? Okay, because we need a p hat. So I'm going to make a p hat up right here. Let's just say our p hat was the same one as the last one, 0.842. So now that we have our p hat, we can find our q hat. Our q hat is 1 minus p hat, which we found was 0.158. I just made this up for the problem. I realized it didn't say it in it. I probably didn't fully copy the problem out of the book because that's where I got these problems from. So I just made this number up, okay? The book probably has a different number for it. So now all we have to do is plug in all of our information in the formula. We actually do need to calculate the z of alpha over 2. If you just remember, z of alpha over 2 is just inverse norm of alpha divided by 2, 0, 1. So I'm just going to give you alpha over 2 real quick. If you do 1 minus 0.9, you get 0.1. 0.1 divided by 2 is 0.05. So z of 0.05 is equal to inverse norm of 0.05, 0, 1. This is negative 1.644. Inverse norm, 0.05, 0. Yeah, negative 0.044. And we're just going to make it positive. Okay? So I'll add that over here to our information. Listen, we don't need this anymore. Z of 0.05 is equal to 1.644. So n is equal to p hat 0.842 q hat q hat 0.158 times my z of alpha over 2. Z of alpha over 2 is 1.644 divided by my error 0.03. Then I'm going to square it. More than likely, it's going to be a decimal number. But if you recall, we talked about whether we're going to round up or round down. Right here. 399.5124. So, try to think. Remember, what did we say? Did we round up or did we round down? You're always going to round up. So we need to survey 400 people to ensure that any confidence interval that we construct with this population proportion will be within 3 percentage points of our point estimate. Okay?